several years later, another neurologist working in Germany by the name of Wernicke made a second discovery. He found a patient who had a lesion in the parietal temporal area, just where the parietal lobe meets the temporal lobe. And this patient had a language difficulty that was very different from Broca's area patients. Broca's area's patients could understand but not speak. This person could speak, but he could not understand. So what he would speak would really make very little sense. When he came to autopsy, Wernicke found two interesting things. One is that the lesion again was in the left hemisphere, and the lesion was, as I indicated, in the parietal temporal lobe, and he called this Wernicke's area. The remarkable thing about Wernicke is not only did he make this finding, but he used this finding and Broca's finding in order to develop a theory of language. What he said was, look, this occipital cortex right here is this place where visual information comes into the brain. And this temporal area is where information of hearing comes into the brain. So when you hear somebody speak, or when you read something, that information comes in from specific sensory systems, and it is brought to Wernicke's area, where it is translated into some sort of a neural code for speech. That neural code for speech is then passed on to Broca's area through a pathway called the arcuate fasciculus. And then in Broca's area, it is translated into language, which can then be articulated and spoken. So he really picked up the idea of localization of function, but elaborated in a very interesting and sophisticated way. He said a complex function, such as language, is not mediated by a single area. It's mediated by a combination of areas. So we see here for the first time the development of the idea of distributed and parallel processing, an idea that now dominates thinking in modern cognitive neuroscience.